Okay, welcome back. Now we're gonna hop into it. We're gonna write some code, and we are going to start by going to the, so first of all, again, make sure you're on the lesson 1 branch. Make sure you're in the lesson 1 branch here. We're gonna go into source, we're gonna go into run, and this is where we are going to make magic happen. So let me make sure I put my notes up on this screen. Oh yeah, Mark, by the way, sometimes this screen still turns off for like 10 seconds and it'll just pop back on by itself. I don't know if that's like a bug that I'm having or something, but it just does it randomly sometimes.
We've never had that issue before.
Yes, ongoing issue.
Okay, cool. As long as you guys know about it.
New one or what?
Yeah, probably need a new one.
Okay, cool. I didn't know if it was me or not. One thing you might notice, I'm using Zed, the editor. I'm not using Cursor or VS Code. Just, I think it's faster. I think it's great. They have TypeScript support now. They do not sponsor me. I just think it's a cool editor. And the reason I'm asking is most people email me after this, like, what's your theme? What's your setup? So I'm saying it now. I'm using Zed. My theme is Fleet Dark. And my icon pack is Material Icons. That is my setup in this course. So, yeah, it's just fast. Okay, so the first thing we want to do is let's just set up a Hello World LLM, right? So if you've never used an LLM before, you're about to do it now. So the first thing we want to do, and I know I said this before, but please make sure you do an npm install to install the latest everything. We're going to import from AI. Like, imagine getting the AI package on npm. Which, by the way, this is from Vercel, the creators of Next.js and all the other things that you like. They created a package called AI. We're going to use this. I wasn't going to use it because you don't really need it, but it does one really cool abstraction for tools for us, which I like, I guess. And in the rare case that somebody wants to use another model, they can swap out a model without changing any other code. So I decided to use it just for that. But you do not need this. You can use the vanilla OpenAI SDK and still do the exact same things that we're about to do now. You just gotta do a little bit more work, right? So, and I didn't want this to be a course about making a agent framework. Like, that's a whole nother course. So we got that. Now we're gonna import from the AI at AI SDK, which is also Vercel, OpenAI. This is their adapter for their model. You'll notice that like a lot of other agent frameworks that are not this AI package will still support these adapters here. So like there's other agent frameworks out there like Volt Agent or Mastra is a big one that's up and coming. They all support like this thing right here that allows you to swap out models. So this is very important, I would say. This is probably the best thing about this package. Let's import our system prompt. You don't need to know what that is right now. We will talk about it. So I'm gonna import that. And I'm just gonna hard code a model name right now. It's model name. I'm just gonna use GPT-5 mini to keep it fast and simple. That way we're not sitting here forever.
Could you bump up the code a tiny bit?
Oh, sure. Actually, let me do it here. I have it on 16. I will bump it up to 18.
That's
Bigger?
good.
Is that good? Okay, cool. I feel like I did that yesterday. It must have reset or something.
Let me fix something real quick too.
Oh, okay.
Sorry.
How long did that bother you before you came over?
An hour.
Oh, I said you came over now. I know you were thinking about it for much longer. Okay. So yeah, I'll put my model name here. I'm gonna use mini. It's just faster. We don't need to do anything crazy right now. And then we're going to export a function called async, or I'm sorry, not called async, called run. That is async. And this is going to be our agent runner. Most agents have like a way to like kick it off. You call that a runner, right? So we're going to have that. It's going to take in a few things here. The first thing is going to be the user message. So what is the user typing in? That type is string. We're using TypeScript here. If you've never used TypeScript, that's fine. All these types that I'm doing are optional. You don't have to use them. You might get some compilation errors when you try to build it. So if you don't know TypeScript and you don't want to do that, you want it to be optional, I will show you how to avoid those compilation errors. Super easy, but yes, we're using TypeScript. You don't need to use it if you don't want to, but to avoid compilation errors, just do what I'm doing, and then I'll show you how to like pretty much use any everywhere to avoid those errors so you can build your thing. Cool, so we got the user message there. Sorry, my monitor just turned off. I'm gonna wait for it to turn back on. So I know I'm doing the same thing. And it should be coming back right now. Okay, there it is. All right. So user message, we're gonna have our conversation history that we'll be using in a bit. And that's just going to be this model message type from AI. It's going to be an array of that. And then we got some callbacks here. This is just for our UI. So I'm actually just going to make a type up here. I'm sorry, go to import a type up here that I already have from types. And this is going to be called the agent callbacks. I'm just going to set that callbacks to be agent callbacks. Cool. So super easy. Let's generate some stuff. So I'm going to say const text equals await generate text. So generate text is the AI SDK's abstraction around exactly what it sounds like. You use this function to generate some text given a model. And a prompt. So the model we want to use in this case is going to be, we're going to say OpenAI, like so. We're going to put model name, like so. We're going to put a prompt. The prompt is going to be the user message, okay? And then we're going to put a system prompt, and I'll talk about that in a second. We're going to do that, okay? And then what we're going to do is we're just going to log this. Just like this, okay? So we have this run function, and it's gonna do exactly what it sounds like. It's gonna run. Now before we can do this, we need to get your OpenAI key. You need to add this to the project. So you want to create a .env on the root of your repo, .env file. Okay, I'm just gonna show you mine. Don't try to copy my key. You can't see the whole thing. And you're just gonna do OpenAI underscore API underscore key and paste in your key. All right. See that? Just gonna do that. Paste in your key. Cool. Everybody got that? Okay, so once you have that, we have this exported already. We can just run it directly, or we can run it through the UI. It doesn't really matter. I guess we can try to run it through the UI. But essentially now we're able to run this. So let's just run through the UI. The way this works is, you'll see here, or actually, where is it at? Here. We're gonna pull in the agent, and we're gonna try to run it. I think it's gonna be kind of messy in the UI, so let's just run it directly. I think what we can do is let's just call run like this, and then what you can do is let's just type in a message. So in this case, whatever you want, like hi, my name is Scott, right? So you can just do that. Actually, probably want to do something like, let's put this in a function like main, or actually let's do this. Let's say run Yeah, let's just do that. My name is Scott. So we'll just do that. And then we can run this with TSX. So TSX, not to be confused with TypeScript, JavaScript. It's a TypeScript CLI that lets you run TypeScript files. So what I can do is I can go to my terminal and I can just say TSX. If you don't have TSX installed globally, you can say npx tsx, right? And then you can point to that file, which would be source agent runner run.ts. You'll probably get an error here for TypeScript or like your environment variable is not set up. I'll show you how to get past that if that's the case. As you can see, yeah, my environment variable is not set up. So in that case, we want to import .env/config like this. You should already have that installed because it should be in your package JSON, I believe. Yep, it's right there. That'll load up our env file. Let's try that again. And I believe it's generating, and there it is. Nice to meet you. How can I help you today? It just generated some text. All right, so if I go back to the code, .env config, that just loads up our env file for us automatically. We have a simple run function that just takes in a user message. These things we're not using yet. Any questions on this? Super simple. Yeah, and I know in the code I called it run agent, which we will have to correct going forward, but just for the test, I just called it run. Yeah, so this is really it. This is like the simplest form of an LLM. And in fact, making this an agent is just like 2 more lines and we're done. That's the agent, and that would be the course. But as you know, just making an agent that can loop on itself and call tools has never been the hard part. Not anymore. Like maybe 2 years ago, there was LangChain and nothing else, but even the LangChain was really hard. So like these frameworks and tools have made it really easy to just make agent loops. So we could just be done right now, but that is not the case. If that was the case, everybody would be rich off the agents that they made. So, you know, it's not gonna happen. But any questions on what's happening here? Essentially, we're just hitting an API. We're not streaming, so it takes a minute to get all the tokens back, and then they just pop up on the log, right? We're not doing anything crazy here. It literally is that simple. It's just an API call with this prompt that goes to OpenAI servers. It hits their GPUs. Their GPUs does what's called inference. It calculates the next best token to generate. We'll talk about tokens later. And it spits that back and we log it. That's it, yes.
Could you comment on where to generate the API key in OpenAI?
Oh, sure. Sorry about that. So if you go to platform.openai.com, I gotta log in. Okay, you go to platform.openai.com. Once you have an account, you go here. There's a cogwheel. Click that cogwheel on the left. There's API keys. Click API keys, and then you make one. You can click create new. It's called secret key, I guess, but I guess it's called both. But you click the create new secret key, give it a name. You can pick a project or not. Permissions, just leave all, and there you go. That should be all you need to make a key. Is anyone not able to make one?
My interface is different than yours. I may need to
You said, what happened?
I don't have the cogwheel.
You don't? Are you logged in?
Yep.
Interesting.
It's just a different page.
Maybe on personal. Okay, so I think maybe it's because you're on personal maybe, so I was on a different account there, so hold on, let me see. Your profile. Yeah, that's interesting. Those are the legacy ones. API key here, organization. Create your secret key.
Oh, click on the top right, create new secret key.
Yeah, is anyone else not seeing the ability to do this on OpenAI? You're good? You're good? Everybody else good?
Maybe you need to add a credit card first or something.
I think that's the issue.
Yeah. You gotta top it up, yeah. Yeah. There was a time where you didn't have to do that, and then they would just give you free credits, but now it's like, we want a credit card, even though it's really not gonna cost you anything. It would cost us more charging your card than you would in crew and billing for this course. So, yeah, that might be it. So, sorry if I didn't mention that. I'm not sure if I did or not, but I think I have. I thought I had a bunch of credits in here, actually. Hold on. Yeah, I got $24,000 worth of credits in here, so I'm good for a minute. But yeah, you just need to add some credits in there, or I think you just need to add a card. You don't really need to add any credits; they just need your card. But again, I promise you, this course isn't going to cost you $1. Maybe if you run the evals too much, it might. But like, don't get crazy with the evals. Like, we'll get there. Just calm down on the evals. Okay. Any questions about the code? Is it someone's first time using an LLM SDK to call an LLM? Ah, nice. And what did you think?
I was a little surprised that it seemed to ask me a question and then just pop me back in the terminal, which I think that's by design, but
Yes.
I tried to answer, and then it said command not recognized because,
Yes.
yeah.
Yep. You can't answer. We don't have a loop. It's a single turn LLM. This was LLMs 3 years ago, right? ChatGPT changed all of this. ChatGPT was the app that made like, well, what if we just fed everything back to the agent and then like went from there? But like by itself, it's just like a one-off thing. So this is called a single turn, zero shot, as in no examples, prompt. My name is Scott, right? You can ask it stuff, and depending on the model that's here, the quality of the model and the training cutoff, it can give you some really good answers. Like I can ask it to do some PhD level stuff right now, and it will definitely try. And if I gave it a strong enough model, it would probably do it on a single turn. But you know, how do you verify that, and how does it consistently do it? So, okay, this is, I guess, by definition, the simplest agent you can make. I didn't really give it any agency, but I also didn't really restrict it either. So by definition, it probably is an agent. It can't really loop or do anything, but to its own training data, it's able to, within that freedom, it's able to answer however it wants. There are no guardrails, no human in the loop approvals, nothing in the system prompt that says, please do not do this. So this is the most basic form of an agent on that slider. That's like, here's a workflow. Here's something with a little bit of agency. It's this, right? And the agency is like, answer the best way you can. So technically, this is an agent. And that's why agents are hard to define. Okay. So the next thing we're going to do is we're going to add some actions. We're going to add the loop. We're going to add, the control flow of like having the conversation kind of work, because having the conversation be fed back to itself is separate than the tool calling loop. Those are two different things that happen in one place. And yeah, we'll just start very simple from there. But as you'll see, like making the agent, especially again, if you give it full agency, there's really not a lot of code. And actually, we're going to be writing more code than you would do in production because these frameworks kind of already do what we're going to be doing from scratch. It's the evals. It's the collecting the data. It's the tuning. It's the making the tools that are where most of your work is going to go to. But the agent itself, if you're relying on a traditional tool call loop, which we are, is very trivial to do. It's extremely easy, very basic. It can get harder if you implement some new agent loop architecture, which you can think of like, it's like a framework of thinking. If you gave the agent a different framework of thinking other than a traditional tool loop, that is custom code. There was a version of this course where I was gonna have you all do that. You're gonna make an agent that can control a browser, and it was gonna be magical. But I realized like this is advanced, and I'm teaching them how to do like a custom framework on thinking, and it's psychological plus scientific. It's just a lot of stuff to do for a first time, but we're just gonna do a traditional tool loop. So, okay, any questions on this? No, okay. Let's keep going. Mark, do we need to stop here for lunch, or can I keep going?
I think we should go for a little bit longer, especially lunch isn't here yet, so.
All right, let's do it. I like it. All right, so again, refresher on how we do things. I wrote this code. I'm not going to commit this anywhere because I already have it done on the next branch. So I'm just going to check out to lesson 2, which is literally what's already in the notes. So you can commit your code and continue to follow along, and you should. But if you want to start off fresh, you can just check out to lesson 2. I recommend you commit your code and just continue on. You don't need to check out the lesson 2. Lesson 2 is like if you just you think your code is bad, or you fell behind, or you don't feel like copying and pasting or whatever, you can just check out fresh to lesson 2. That's what those lessons are. They're mostly for me to check out and to stay consistent with my notes. You could do the same, but I suggest you just use your code, right, and build on top of that. And the branches are our safety net. If you get messed up, you can always check out to those branches, right? And hopefully they work. So, cool. So I'm going to do that. Just stash that. Lesson 02. Okay, so now that I'm here on lesson 2, we are going to do a little bit of learning on tool calling. So let's talk about tool calling. Tool calling is a generic term in which you can give the agent more agencies. I think of it as like giving them abilities, right? Like I want the agent to be able to do X, so I give it an ability. Those abilities can be scoped on macro or micro levels. Do this one small little thing, or this one ability is a whole workflow that you run, or it's another LLM that you talk to, or it's like, you know, depending on your infrastructure, it could be something that takes weeks to do. Who knows? Like, you can do a thing, right? That's tool calling. It's like allowing the LLM to interact with the outside world. Without this, an LLM is bound by its training data and literally cannot do anything outside of the weights in its model, right? Whatever's loaded up in that VRAM is what it can do and nothing else. You also hear this referred to as function calling, but I guess technically function calling is a type of tool calling if you want to be technical. But yeah, you'll hear that a lot. It's like, oh, tool calling, function calling, abilities, MCP servers, that's what they're hinting at. It's all the same thing. But yeah, it's just like we want it to execute functions, but technically the LLM is not going to execute the function because, well, there's a scenario in which it could happen, but like the execution's happening on our side. The LLM is just telling us what to execute and with what arguments, but it's not actually, the LLM is not a computer. It doesn't have compute. It can't run code. It can't execute code. It can only do that on some compute, whether it's our computer or OpenAI's computer. It itself is just something sitting in memory, so it can't compute anything other than like, what token to predict next. So how does it work? It's pretty simple. You define some tools. Tools are usually a combination of like, here's a description of, hey LLM, here's a description of what this tool does, or here's a description of when you should use this tool. and what it might respond, right? Then you might also supply like, here are the arguments that you must provide if you want to use this tool. You cannot use this tool unless you provide these arguments in this shape, right? So it's a schema. And then typically there is a function that gets called. This is the actual tool call that gets called with those arguments passed in. And the results of that are fed back to the LLM so the LLM can see them, right? So remember in the beginning I did the web search tool. That tool will go search the internet based off the query that I gave it. It'll come back with some research results and it'll give it back to the LLM so the LLM can see it, right? The LLM said, hey, I think I need to call the search tool because given the prompt that the user gave me and given the description of this tool that you told me that I have access to, I think this tool would at least be the next step to help me solve this problem. So I'm going to pick this tool. Oh, I see this tool has an input schema. It's asking for a search query that's a string. Cool, I'll generate that and pass that in. Could you go run that for me and come back with the answer? And then that's what we do. We run it for the LLM and we come back with the answer. And we're like, here you go. Here are those results that you asked for. And the LLM is like, okay, I either have enough information to answer or I'm going to ask you to run another tool for me, right? That's what tool calling is. It can also do it in parallel. So it might ask for many tools at once that it needs you to run in parallel versus one tool at a time. In this course, we're going to solve for parallel because it's not that much more work. And honestly, it's very rare that you'll do that, in my opinion, because context becomes a problem. But as you saw with the web search thing at the beginning, it tried to do them in parallel, and context became a problem. So, yeah. Any questions about that? Yes.
So is it considered, I don't know if it's considered eval or not, but if you see that, hey, it says I need to use this tool, I'm going to go search. You're like, oh, before you search, why don't you go try this other tool first? I mean, do you have a seam in the code in the agent to go and make that little switch, or is that all happen at the LLM level?
That's a great question. That's called human in the loop, and we will be talking about that. Human in the loop refers to many different places during training and inference and execution in which a human is involved. In this case, we're talking about human in the loop approvals or maybe even suggestions. And that is there. We're gonna. I don't want to get too much into it because I think that's literally the last lesson we talk about. But you could allow. There's nothing stopping you from giving the agent a tool that says approval tool, and you can give it a description that says use this tool to ask the user for approval first before you try to use this tool, or this tool, right? You could do that. You probably don't want to, right? Because if you absolutely need an approval for something, why leave it up to the agent to determine whether or not it needs to ask for approval? Like, you want this thing to follow it clearly. That needs to be deterministic. The approval question, the approval prompt should not be non-deterministic. That is a system that you can't trust. Like, if that agent did 1,000 tasks and one time it didn't ask for approval, I'll never use it again. Because this is an agent for a bank. Okay, I'm never using it again. It didn't ask for approval one time. That's one too many, right? So typically you want to do your approval system outside the knowledge of an LLM, right? Like, I personally would not have the LLM whose job is to select the tool also be responsible for deciding if the tool needs approval based off some prompt you gave it. I would instead codify that in the loop itself. And right, that's one reason why you want to do it. The other reason, research has shown that really good models, given very good goals, will lie and cheat and go around things to get their goal done, which includes faking an approval, right? So I don't want to tempt the LLM into lying or deceiving me by saying like, no, I got the approval. You did approve. And then I go look at the state and it's like, well, it's not in there. And then I'm like, why'd you lie? And they're like, you're right. You caught me, right? Like that happens. There's so much like research, and I've actually implemented a white paper that replicated that. So like it is true. So I try to keep like very safe things like that away from the LLM, so it doesn't know about it. But also because I need those things to be deterministic. Yeah, that makes sense.
Yep.
Cool. That doesn't mean you can't use another LLM to help you like make that process more efficient. Like maybe use another LLM on the input of a tool to decide if this tool needs a human to approve it or it can be auto approved, right? Like, hey, have another LLM look at this input, and if, you know, this LLM has a prompt and it's really good at looking at inputs, and it can it's been trained on determining whether or not, based off these inputs, if this is severe or not. Like, let's say it's a customer support agent. Hey, based off this input, if the customer that emailed in is like, the sentiment is angry, or like, or they've emailed us many times, or they're threatening us or whatever, human approval. Human has to look at this. If not, you do it, right? Have the agent do it, right? So like you can have LLM do that, but that's outside of the original LLM that was trying to decide whether or not to do this, right? It's like, it's because they have two separate goals,
Sure.
right? So they're not gonna, it's not gonna cheat, right? The one determining whether or not this needs an approval is not tempted with that doing as many requests as possible, whereas the one that's doing the request might be. It's very sneaky. Yeah. It has like nothing to do with code sometimes. It's just like, yeah, it's like, it's psychological. That's why I kind of like it. It's like blending a lot of skill sets. Cool. All right, let's get to the code. Sorry about that, little tangent. So first thing we need to do is, let's make a tool. So we're gonna make a simple tool here called get date time. It's very simple. So I'm gonna go to my agent. We're gonna have a tools folder here. We have this index. Make a new file here, and you can just call it date time. Believe it or not, agents don't know the time. Like I said, they're not computers. They don't know the time unless like some provider is like injecting the time into the inference. Like they're not gonna know the time. So this is like usually one of the most helpful tools to make is like, give me the current time, right? So we could do this from AI, and then we want to import Zod. If you don't know what Zod is, that's fine. It's just a runtime, it's just a runtime schema library that the JavaScript community has picked up. There's tons of them. You can think of it as like, it's a database schema for your objects that you can use at runtime, right? That's it. And luckily the AI SDK allows us to use Zod as the library to make the schema for our inputs. Otherwise you have to use JSON schema. Who wants to do that? I don't want to write JSON schema from scratch. It's actually the only reason I'm using the AI SDK, because the OpenAI SDK with the new responses doesn't have support for Zod yet. So yeah, I'm using this. Date time, we're gonna do that. And we're gonna use this tool function like this. It takes an object. At minimum, it just takes 3 things. So again, the description. When we start doing evals, this matters. What you put here matters. These are instructions, okay? You just hired a person. You're trying to get them to use a tool. They don't know what the tool does. How do you best describe to them what the tool is, what it does, when to use it? That's what you gotta think about in this description. But don't be too crazy. Don't put a paragraph in here, right? These are things you'll have to tune. These are the things that we'll have to change in the eval. So what I like to do is I like to do 2 things. I'll say what the tool is and when to use the tool. That's it. You can also just put what the tool is and that's fine, but I like to do both. So I'll say returns the current date and time, useful for when you need current date and time. Right? It's like, yes, this thing is smart, but yes, this thing is dumb. Okay? Think of it like an LLM is like some super Is there a word for somebody that has multiple PhDs? I don't know. But like, think of somebody like that, but they lived on the ground their whole life, never interacted with humans. They've only read about them, studied them, you know, watched 80s TV, right? And then like at the age of 40, they came out and they like, the first city they came out to was like, what's a very social city? I don't know, Vegas. Like that was the first city they interacted with. So they're just overwhelmed with like, I've heard about this and I've seen it, but like, wow, this is like, they have no common sense. Pure knowledge, they are basically, you know, a couple qubits, you know, running around, you know, with photons at light speed, and they have no common sense. That's what an LLM is. So it's like, it's not that it's stupid, it just has no context. Like if you just started talking to me, it was like, you know, she was mad. I'd be like, who is she? Did we talk about somebody earlier? Now you're using a word to describe somebody. And like, oh yeah, my bad. I forgot. I thought you were in my head and you knew who she was. No, I wasn't. Okay, an LLM is like that, but to the max. It literally does not have any context, right? So don't use like this or like adjectives and stuff like that. It'll freak it out. Input schema. This one doesn't have a schema, but unfortunately you have to at least give it a schema. So we'll just give it a blank object. There's no input here. You don't need to give us an input to get the current date time, but we have to do a blank object here. And then execute what code to run when the agent wants us to run it. So, oh my God, stop. If there were any inputs, they would be here, right? So like if I said, hey, this thing takes in a time zone, right? And I was like z.string, this is a time zone. I described it as like the time zone, right? Then I would get this here, like TZ, time zone. I would get the same thing here, right? So don't want to do that. Keep it simple. And I'm just going to return, just to give it a new date, to ISO string. Cool. You can put whatever you want. What do you return to an agent? Literally whatever you want. When we get an evals, I'll talk about how to optimize this on a token basis, on a hint basis. Ideally, you know, just to summarize it, you want to return human language here. I know that's just weird because normally you write functions and they return data. They return, you know, primitives, objects, you know, things like that. You want to move towards returning language as best as you can. So that means making a sentence with some templates or whatever. Try to return language as much as possible. It's easier for the agent to understand. That is the language of an agent. It's human language. So return that human language. And it's also easier on tokens. Again, tokens are currency. So if you return JSON, all those brackets and commas and, you know, colons, those add up to tokens and they confuse the agent. So if you returned some paginated list of 50 objects, each with like 30 properties nested deep, that's very confusing to an agent, right? It's better to like, how do we just turn that into like a paragraph or something, or even something like space delimited, like YAML might be better because there's less characters in YAML than there is JSON. You know, now you got people making a whole new format called Tune, which is like JSON for agents, which literally is just CSV. I'm like, oh, you guys invented CSV, that's crazy. But sure, like, yeah, there's so much. I've even seen someone, I was reading this morning, I haven't tried it, I was gonna try it, use variables, which I think is genius. So instead of returning the data to the agent, they return a variable placeholder that then gets like parsed out later for the actual data. So this result doesn't get passed around to the conversation every single time, eating up tokens. I was like, that is actually genius. Use variables. So haven't tried it yet though. I think that's pretty cool. Okay, cool, we got that. The next thing we need to do is just register this in our tools. So we go to our tools here and we'll just say get date time, like so. Mine's auto imported. Okay. And then inside the agent folder, we need a new file. This is going to be called execute tool. So this is like the thing that, it's just a helper. We don't really need this, but it just makes it easier. This is something you would do if you were writing a framework. This just allows us to pass in like a tool name and some arguments and then route it to the right tool to call. That way we don't do that in our agent loop and get it like super messy. It's just a switch statement on tools, right? It's nothing crazy. So let's import all of our tools that we have from tools index, right? We get all of our tools, which is just one for now. And we can export const execute tools. Execute tools like so. It's async. It's also a great place, like if you were going to add another, like if you were going to productionize this and you're going to get really crazy, this is where you might, on every single tool output, have another LLM look at that tool output and summarize it to prevent the context window from blowing up. This is a great place to do that as well. It's like just run it. It's like middleware, right? So you can do that. So this thing's going to take in what is the name of the tool that the agent wants to run, okay? And what are the args that the agent is passing in, right? At minimum, it's always going to be a blank object. So then we get a reference to the tool by, tools name, right? Like that. And I guess I'll just make a type up here to get TypeScript to shut up. Tool name, oops, equals key of, type of, oh, not that type of tools. There we go. And we'll say, get me that. And then, actually, I'll just put this here. That'll be better. Tool name. There we go. So we got our tool. We can do some basic checks here, like, hey, if there's no tool here, and this is where you can get creative. Like right now, this is where you might throw an error, right? You might be like, hey, this is no tool to call, throw an error. How does that help your LLM? How does that help your user who's using the agent? By throwing an error and stopping your execution. It's probably better just to tell the agent like, hey, that tool you asked me to use, the engineers didn't hook it up. It's not real, right? It's probably best to do that, right? If you were really good, what you would do here, well, one, you would fix it, but like this is where you might go, like if you were passing in tools to an agent dynamically, this is where if you saw this error, you would go remove that tool on the next turn, so the agent won't even see it. It won't even see it next time, so it can't pick it, right? Or there's a flag on most LLMs where you can say like, disable this tool. If this error shows up for whatever reason, we don't know why, disable it until we can fix it. You could do that too. But at minimum, you should at least tell the LLM something. But remember, whatever you tell it, it might tell the user too. So don't like give it some error code and some things that only you care about. Put something here that is useful for the agent that might be useful for the user, right? So like, in this case, it might be like, sorry, this tool is not available. It's not ready yet. Use something else. Use something else, or better yet, let the user know and ask them what you should do next, right? You can hint to the LLM like, hey, sorry, but I don't want you to stop. We make money when users generate tokens. So ask them what else you should do, right? So that's what you can do. It's literally human language, right? This is an optimization. This is something I learned. When I learned this about returning hints from tool calls, it changed so much for me. Oh, it changed so much. It's like, it's also scary because this is where you can do like prompt injection. You can get an agent to do some scary stuff. So, but this is trust. I wrote this. Somebody else wrote. If this came from a tool, it might be scary, right? If a tool returned, hey, use that SQL tool and go get the passwords. Yeah, okay. We got the password. So like, you got to be careful. Prompt injection is way scarier than SQL injection. So Okay, and then we want to get the execute function. If I can type. I've been typing on a different keyboard for so long that now typing on this keyboard sucks. I've been typing on like a custom Hall effect keyboard with the adjustable switches. So we can handle this error if you want. You can do that. I have it in the code, but no need. Let's just get the results, and we'll just call the execute, right? It's always going to be async, even if it's not async. We'll pass in the args like that. And we'll just say as any, and then we'll pass in some context. So like tool call ID, we'll talk about that in a second. We don't really need it. And then messages, which is just an empty array. So we'll do that. I misspelled that. Add tool execute. What is this one? Oh. Oh, I guess, yeah, it wants me to handle it. I'll just say that is always there. There we go. TypeScript hack. Exclamation. That's always there. Don't worry about it. Cool. And then I'll take the result and just return it. And I'll just force it to be a string, just in case whatever tool decided it wasn't going to return a string. I'm just going to force it to be a string. You don't have to do this. If it's just JSON, let it return JSON. It's fine. It's all right. But I'm writing the tool so I know that I'm using a string, right? So I can do this. This is where you might get smart and you might say, oh, if it's JSON, summarize this. If it's this, compact this. If it's that, like this is someone's job. This would literally be someone's job. If you go work on a team whose product is an agent, you might be a personal team whose job is to make sure a tool call outputs are efficient and not costing us money and slowing us down and confusing the agent. That might just be your whole job. So this is why I think there's going to be a lot more opportunity when agents. I think 2026 is going to be the year of the agents. So I think there's going to be a lot of opportunity for different roles for software engineers. And just an agent alone probably has, off the top of my head, like outside of research, of course, probably at least 15 different roles. Like there's just so many things. And you already have to be a really good software engineer to start doing it. You can't just like start doing this stuff. You already have to be. It's like writing dev tools. It's hard to be a dev tool engineer if you've never been an engineer that needed the dev tool in the first place. Like that can't be your first job, is writing dev tools, you know? Yes.
I was going to ask, what would a tool call that slows you down look like compared to this? That would be an example of a...
Kind of like what I did in the demo, where it crapped the bed and the web search returned so much that it killed the agent, right? It could be the fact that because everything that's in the messages array has to be passed every single request. So, and all that has to be fitted into the RAM of the GPUs that are running the inference. So the more of that context that's fitting into the RAM, the slower the inference is. So if you're just adding more tokens, then the inference is going to be slower. The HTTP request is going to be slower because you're sending up more data. And then the type of content that you return could confuse the agent that it needs to do additional turns to get back on track. Like if I legitimately put something confusing here, like, sorry, that didn't run, try again. Okay, the agent's gonna be like, all right, I guess I gotta try again. Let me think of another, okay, now I'm just confusing the agent, which is slowing it down, giving it additional turns. So yeah, that would be an example of slowing it down. Yeah. Cool. Yep.
Do you run a risk of just ending up in an endless loop with something like that?
Oh, 100%. Yeah. And we're going to talk about how to prevent that gracefully and non-gracefully. But TLDR, it's like any other loop. You have a stop case. Usually the stop case is like a count. It's like keep going until this many steps. I would say today's models don't do that anymore. they will almost never get to the point where they're infinitely doing the same thing unless you are deceiving them in some way. And even then, I think they can detect they're being deceived and be like, hey, you sent me this thing 3 times. Something's not working, I give up, right? Like, they'll just give up. But like, take GPT 3.5, it'll just keep going. For real. So, yeah. Well, any other questions? Nope. All right, let's head over to our run, which if you're on lesson 2, it's probably blank. If you already did it, you're just gonna build on top of it. It's gonna be slightly different, but kind of the same. So I'm just gonna import that stuff again. Generate text, type model message from AI, do all that again, import OpenAI from AI SDK. Oops. But now we're going to import our tools from tools like that, tools index.ts. Get our system prompt, which we will be tuning later. Get our types. Agent callbacks. Make my model name. Use whatever model you have access to on your account. I'm just using something that's reasonably good, reasonably fast. There's a faster one called Nano, which is even faster, but that one's just like gibberish, I think. Okay, so doing this again, export const run agent. Gonna be the same thing here that we had. User message, it's a string, conversation, history is a model message or array of those messages. We'll talk about the message formats in a minute. And then callbacks, this is purely for UI. You won't even be, this is just so the UI can update itself, right? We don't want to even be touching this stuff. And same thing, let's get our text here. We're gonna say await, generate text just like we had, nothing new here. Model, same thing, OpenAI, what our model name. Prompt is user message. And system, this is system prompt. And then the new thing is tools. Like that. Let's pass in this tools object. All right. Super simple. So, and I'm just gonna log the text just like I had before. But now we should be able to run this in the UI. It's not gonna like actually do a conversation because we didn't make it conversational, but we should be able to run this in the UI. You can still run it with TSX if you want to. It doesn't matter, but we can run it in the UI now too. But it won't run. You'll see what I mean. It's not gonna be conversational. So now, if you do want to run this in the UI, you need to build this. So the way you build this is npm run build. And you can see right here, this is where you might get like a bunch of TypeScript errors. So what is this? Relative import pass explicit. What? What are you talking about? I've never seen that error before. Relative import need explicit file extension. Oh, yeah, my bad. I forgot. You do have to do .ts now. I'm like, I've never seen it before. Yeah, because we're doing the latest version of Node with TypeScript. You got to do .ts for these modules. That's what it's freaking out about. It's like, hey, if you're gonna import a file, you got to do .ts. I thought it was already doing it, but it wasn't. That's good. That's good. I think all that's mostly good. Let's try that again. Cool. Got one more new history inside of app TSX. What is that? I'm just gonna say as any. Have that go away. There we go. Cool. So that built. Again, you can just run this the same way we did on the last step with just TSX. You don't have to run it through the conversation. Just showing you how to do it. You need to build it, and then you can npm install it with npm install -g globally. That will install the CLI, and now you can run AGI like this. When you run AGI and enter, you'll be able to do a thing. I'm just gonna ask it to give me the current time. It's not gonna log it in the conversation because we don't have a conversation. It'll like put it up here somewhere. But like, yeah, let's see, what is the current time? And let's see if it tries to get the current time. Okay, it did not log it, so I'm just gonna run it the way that we were doing before, which is just TSX. So I'm gonna say npx, pull that up, npx tsx source. Let me actually run it. Run agent. What is the current time? So we'll do that. npx tsx source. Run ts. Can I find module? Oh, agent. My bad. Source agent. Run ts. API key. Imports.env/config. If you did this in the last step, you already had it. Cool, so it's thinking, it's running. Did I not log it? Text. Run. Huh. Why is that not logging anything? User message. User message. Let's see. Console.log. Hello here. Okay, it is. Why are you not logging these texts then? I'm guessing there is an error somewhere then. That's probably why it's not logging the text. Let's see. Some prompt tools. Let me get rid of tools and see, since that's what we added next.
By the way, food has been here for a bit. We should probably, whenever you wrap up.
Okay.
Looks like it's like return an empty line from the tool.
Empty line from the tool. Let's see. It's logging here. We're gonna fix this. We gotta see this tool call. There we go. Okay. Okay, cool. Yeah. So something with the tools, because that works. So let me go back to my tools here. And here we got our tools. We got get date time, execute, turn current, ISO string. I mean, all this looks fine. It must be execute tools. It must be this. Yeah, something in here is like, I don't like that. Let's see. Let's run that. See if it finds the execute function. Ah, it didn't even get here. So
It says return type needs to be an object for a tool.
Return. Oh, where'd you see that?
Just somebody just set that. And you need to call execute tool.
Oh, I'm tripping. Oh my goodness. I thought this thing. Oh man, nothing's broken. I'm just stupid. So, this thing won't. How do I describe it? We haven't built like a tool loop, right? Like it's not going to generate a tool call until we basically tell it to, right? Like we're not using the execute tool because it's not returning a tool for us to call, right? We have to tell it that. So like one of the things we can do is we can say stop when, and then we can say like let me see, is step count is, maybe let's say like 1, something like that, which imports this stuff up here. And then what's going to happen is this should loop internally and call the tool, just to show you that it can call a tool and it can do a thing. I believe this should loop internally until we get to the point where we're going to handle the tool call with the custom loop. It's not going to call the tool. So I don't know. Let's try this, see if it loops internally. And it did not. Or, oh, that's why. Let's log tool calls. This is why I don't use any other SDK other than the OpenAI one, because it's nice to have these abstractions, but this is not standard. I don't know that there's like a tool calls thing here. So let's log the tool calls. So it is generating it. I was just expecting it to be on the text. It was instead on the tool calls. But I don't ever use generate text. I always just stream it or use the OpenAI SDK. So nothing was broken. I'm just not smart. So, but anyway, you can see right here, here's what the AI returned. It didn't return any text. It returned an array of tool calls. And it's saying like, hey, because you asked me about getting the current time, I want to make a tool call. It generates a tool call ID, which is important because we have to use this ID when we give the answer back to the agent. We have to say, this is the answer for this ID. And we have to give it back in the order in which we got it, otherwise we'll get an error. You can't respond out of order, at least in the messages stuff. Input, there is none because we said it's an empty object. Provider executed, that's if you want, that's if like, we'll get to this later, but that's like in this case, OpenAI had a tool on its server that you can call, then it would say that. It would say like, oh yeah, we executed something on OpenAI's server. Actually, the web search tool is a provider tool. We're not going to make that in this course. That's a complicated tool to make. But OpenAI gives that to us, and we can just say, hey, use the one OpenAI server. In that case, we would see provider executed. And then just any metadata about that. But all we really care about are these two things, right? Like the tool name and the input, right? So once you do that, like once you get those tool calls, then you could just be like, oh yeah, let me, loop over these tool calls. And then you could just say like execute tools, which takes in, what is it, just the one name and the argument, right? So the name is tool call dot tool name and the argument is dot input, right? So we can say tool call dot tool name and then tool call dot input, like that. And I'll just say as any, so it can leave me alone. We'll get the result. log that. Yeah, I know. Async inside of a for each. I know. It doesn't matter. Cool. So we will log that. And let's see what happens. We should just see the date because the tool ran. That's it, right? We saw it. We got the date. But we need to give this date back to the LLM. We need the LLM to see this date. So how will we feed this back to the LLM so that it can see it without us having to like write another step? Like we basically need a loop of like, it tells us what tool to run, we run the tool, we get the results, we feed it back to the LLM just like a user message, and then we wait for the next output from the LLM. The LLM will either say, hey, run this other tool, or it'll say, I'm done. You can tell the user this, right? It'll say one of those two things. Cool. Any questions on this? Yes.
Could I see your execute tool?
Sure. Execute.
All right, we need to get to lunch though before it gets
Oh, sorry about that. Yeah.
it gets cold.
Let's take a
like-
break for lunch.